Alrighty. So now that we've hopefully gotten some practice writing those hypotheses, the next thing that we're going to do is we're actually going to figure out how do you test for those. So we're going to do that by doing something called a student t-test here today, something called a student t-test. So again, we're going to go over a lot of background information. There is a lot that goes into hypothesis testing. And we're going to largely do most of the math here on a calculator. So just be prepared for that. Now, in order to test statistical hypotheses, we need evidence to base our decisions on. We can't just say things are wrong in statistics without having sound proof, because otherwise that's just nonsense. Like if you make claims and you can't back them up, what are those claims worth? And so the way that we do this, that we're going to look at today, is we're going to use something that's called the test statistic or the T statistic. You'll see those call that either one of those. And basically what this does is this summarizes the information in a sample. And so basically if you're given a hypothesis test where we're claiming that the mean is equal to something, the way that we're going to calculate T here is we're going to do the sample mean right here subtracted by the claimed mean. So whatever they're claiming that the mean is, we're going to start by subtracting those, because if the null hypothesis is true, that should be very close to one another. If the null hypothesis is not true, there might be a little bit of distance between them. So then we're going to divide that by the standard error, and the standard error you calculate by doing the standard deviation divided by the square root of the sample size. Now, when we calculate T for class, we are largely going to be calculating it using a calculator for the most part, but it is important to recognize where this is coming from. So a T distribution is very, very similar in shape and pattern to the normal distribution that we talked about earlier. So that's just the normal curve here that looks like this. They do vary a little bit, but in general, the shape is around the same. And so all that we need to know for this class is that if a population is approximately normally distributed, the distribution of the t-values for the sample size is going to be distributed with n-1 degrees of freedom. So whatever your sample size, to calculate the degrees of freedom, all that you're going to do is just subtract 1 from the sample size. And the way that we would denote a t distribution is with this notation right here, where it says t is, we have a t-test statistic with n-1 degrees of freedom. Now, we've got this t-test statistic, and that's what we're going to use to calculate as part of our evidence here. So now, when we're obtaining this evidence, the p-value, when you hear me referencing the word p-value, what that means is it's the probability of a result being observed if the null hypothesis is true. So if we're claiming that H naught is true, when we're referencing this p-value, it's the probability that that result would be observed. And so generally extreme values of a test statistic are unlikely, and observing one of these extreme values is usually good enough evidence to overturn a null hypothesis. But we need a good measurement for how extreme is extreme. And so that measurement that we're going to use that p-value is also going to be determined by whether something is one-tailed or two-tailed. So if something is, the two types of one-tail are as if the mean is less than or if the mean is greater than. And In that last video, we talked about how the lower tail, if it's less than, we shade to the left. If it's greater than, we shade to the right. And generally, those p-values are just going to be represented by whatever proportion of the curve that t value is taking up. And so if your alternate hypothesis here, if H1 is two-tailed, whenever you plot your value of t, because we've got two tails, we're going to be multiplying that tail by 2. So whenever we get that value, we're going to be multiplying that by 2. And we'll look at that more in just a second. And so then what we've got to do is we've got to try and make some decisions. So we need some standard for our probability that says, okay, what level of probability for this t statistic is going to work? And we denote that with the significance level alpha here. It's like half of, or I guess 3/4 of an infinity sign. So the significance level alpha here that we denote of a statistical hypothesis, this is the largest p-value that would result in rejecting HO and rejecting the null hypothesis. And this is super important right here. Any p-value that's less than or equal to alpha right here, that's enough evidence for us to reject the null hypothesis. Because this significance level that we're talking about, that's referring to the probability that we incorrectly reject the null hypothesis. And typically the highest that you can see a significance level is 10%. So there's a 10% chance we incorrectly reject the null hypothesis, which means that there's a 90% chance that we were correct. So you'll see it 10% all the way to anything less than 10%. So like 1%, 2%, 3%, 4%, where the probability of incorrectly rejecting is very, very low. And the important thing here is that whenever we're doing hypothesis testing, you need to choose alpha before you test your hypothesis. If you decide that there is a 10% or a 5% chance that you can incorrectly reject the null hypothesis before you run your test, you can't get your p-value and figure out, hey, it's actually above this, so I need to change my significance level. You don't want to force your result to try and get the data to say what you want it to say. You need to pick your alpha first. And that will be very, very important. So we're going to get to some math here in a second, but kind of just to summarize what we've gone over. So to do some hypothesis testing, kind of the blueprint for what we're going to do is the first thing that we're going to do is we're going to state the null and the alternative hypothesis here. And then the next thing that we're going to do is after we state those two things, we're going to state, okay, what's the significance level here? How comfortable am I with having that margin for error for rejecting the null? And then we're going to calculate the value of that test statistic. Once we get that test statistic, we're going to get the p-value. Now, here's the thing. We're going to use a calculator to do both of these things. We can easily calculate the t-test statistic by hand, but the p-value is a little bit more difficult. And for this course, they really only want you using a calculator to do so. So then, depending on what that p-value is, we're going to reject the null if the p-value is less than alpha, and we're going to fail to reject the null if the p-value is greater than alpha. And then once we do that, we're going to interpret our decision in context. We're going to and we got to make sure we express that as a complete sentence. So the first example I'm going to go out of, I'll be frank here, the examples were a little bit longer, so if you want to follow along in your textbook, you can. I honestly just didn't have time to write those. So the first example that we're going to look at is example 1 on page 387. And it says, the manager of a restaurant chain goes to a seafood wholesaler and inspects a large catch of over 50,000 prawns. It is known that the population is normally distributed. He will buy the catch if the mean weight exceeds 55 grams per prawn. A random sample of 60 prawns is taken. The sample mean weight is 56.2 with standard deviation 4.2 grams. Conduct a one-tailed hypothesis test with a significance level of alpha is 0.05 to determine whether the manager should purchase the catch or not. So we're trying to figure out, is it worth it to buy this catch using statistics? So we're going to conduct a hypothesis test. We're going to conduct a t-test to see if this is worth it or not. So let's see here. So step 1, we need to write out our hypothesis. So according to the problem, he will buy the catch if the mean weight exceeds 55 grams here. If it exceeds 55 grams. So the null hypothesis says, or the null hypothesis is that the mean is 55. And the alternate hypothesis here, what he is saying here, he's saying he will buy it if the mean is above 55. If it's above 55 grams per prawn here. Now, the significance level that we've chosen to use here is 0.05. It is 5%. And basically what that means, the probability of incorrectly rejecting this null right here is going to be 5%. So there is a 95% chance that we don't, or that we correctly reject it. So it's a pretty high chance that when we go to calculate this, that we're doing that. So now when we are calculating this, what we need to do is pull up, we're going to use a graphing calculator to do this. So if you've got a TI-84, if you got a TI-83, or if you're using the graphing calc app, it should largely work the same way here. So what I want you all to do, everything that we're doing is out of stat here. And so if you hit stat, again, we should have a list up here we can edit. That's where we can put in some list. We can go to calc, and that's where we can do some regressions, but I'm more interested here in the test. We're going to be performing a test here, and what we're going to be doing is we're going to be doing a one sample t-test here. So I'm going to click on that, and let's see here. When I'm doing this, so we've got to fill in some information here. So the claimed mean here is going to be 55. So I'm going to hit 55 and then enter. And then the next thing, the sample mean here that we calculated is going to be 56.2, because that was the sample mean of the prawns that we got. The SX, the standard deviation here, is going to be 4.2 grams. The actual sample size was 60 prawns. And let's see here. So then the couple of things that we could do here. So we've got the 3 different types of tests here. So again, you can see where if we do a not equal to, that gives us 2 tails for this t distribution here. We can do a less than there, and we can do a greater than there. So when we're calculating, our null hypothesis was that it's equal. The alternate was that it's greater than. So we want to make sure that we've selected that the mean is greater than that sample mean right there, or that not the sample mean, excuse me, the null mean, the claimed mean. And so the t-test statistic here, you can calculate that by hand if you want to double check that, was 2.2 0.21, and the p-value that corresponds to that is that p is 0.015384. And basically with that, what we're doing with that p-value is that if the p-value is less than the alpha there, if it is less than the significance level, what we get to say is that because it is lower, there's a smaller chance of this happening than us incorrectly rejecting. We are going to reject the null hypothesis. So step 5 here is that we're going to reject the null hypothesis. And what we're going to do is we're going to reject that in favor of the alternate hypothesis, which says that the mean is actually greater than. And so then the last thing that we've got to make sure that we do here for step 6 is we need to interpret this decision using some concept or using some context here. So we've rejected the null. And so what we've done is we've concluded that the mean exceeds 55 grams. And what we're going to do with that, so that means that the manager should buy the catch. It's not just by simple luck here. It's not just by simple luck that occurred. So he's going to buy that entire 50,000 bunch right there because we statistically determined that it was not just blind luck. And so then we're going to look at one more example here. We're going to look at one more example. And that's going to be page 388 here, where we're looking at the fat content in 30 randomly selected pastries. And there's a big list there, and what we want to do is conduct for a mean fat content of pasties made at this bakery. We want to conduct a two-tailed t-test of the null hypothesis being that the mean is 16 on a 10% level of significance. So we're going to look at one more example here. So the step 1 here that we've got to do, we've got to first write our null and our alternate hypothesis. Now here they gave us the null hypothesis. They said that the null is that the mean is 16 grams. And that's just the mean fat content. Mean fat content is 16 grams. You can see that with words or you can see that with symbols. It does not matter. And the alternate hypothesis here, they want us to do a two-tailed t-test. So that means that it's going to be the mean here is not equal to 16. It could be less than 16. It could be greater than 16. We don't know which it is yet. So, and all that means, if we're going to put that in words, is that the mean isn't 16. Could be above it, could be below it. So then for step 2 here, the significance level, the alpha here, if it's 10%, we're going to just write that out as a decimal. Alpha is equal to 0.1. Alpha is equal to 0.1. Now, what we've got to do when we're running these t-tests, so I'm going to go back to this real quick. There's 2 options here for when we're running a t-test. There's an option to punch in stats, which is what we had. There's also an option to punch in data here. So if you're going to punch in data here, what you've got to make sure to do is you've got to, I'm going to back out of this real quick. I'm going to hit done. If you're going to use data, you need to go into stat and you need to go into edit. So once you've got all that information entered into your list there, we need to make sure that the claimed mean right here, it's still 55 from the last problem. We need to change that to 16 here. And so our t value here is going to be the t value of negative 0.402. Negative 0.402. And so then the step 4 here with that p-value, it's a pretty high p-value here. It's 0.69. We're going to round that to 1. And so because that p-value right there is not, because that p-value right there, excuse me, is greater than 0.1. So because 0.6, or because p is greater than alpha rather, we fail to reject H naught. We don't have enough evidence here because p is greater than alpha. We do not have enough evidence to reject the null hypothesis because that p-value states that there's a 0.691% or 69.1% chance of that occurring, and because that is not less than the percentage that we could possibly be wrong here, which is that 10% that we talked about for alpha here, we're going to say that it is not correct. We cannot reject it in favor of this alternate hypothesis here. And so to interpret that, since we failed to reject H naught, we cannot conclude that the mean is different from 16, at least for this sample set. Based off of the sample that we took, we cannot conclude that. So in summary, kind of to go over what we talked about today, what we did was that we first off talked about claims. We wrote a null and then an alternate hypothesis. After you do that, you need to state the level of which that you're comfortable testing that on. After you do that, we need to calculate the test statistic and then the p-value, which we're just going to use a calculator to evaluate those. And then after we get that value, we need to compare the p-value to our alpha, and based off of that, make a decision and then interpret. I know this when I first learned this stuff, it could be a little bit confusing. So if you all have any questions at all, please let me know and we can get those sorted out. But you all have a good rest of your day, and I will see you later. Bye.